Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology. And yeah, let me go ahead and rush right through this intro because everyone, we are continuing our CES 2022 coverage. And joining us today is a company that if you haven't heard about them, then hey, this is going to be a great segment for you because we're going to be talking about virtual reality. And I've mentioned this on the show before. One of the biggest problems with virtual reality is the fact that this super immersive technology that is supposed to, put you in a whole new world is kind of cumbersome. It's very annoying to have a giant digital tether on the back of your head like you're someone out of the Matrix. And ladies and gentlemen, I think that our guest today has a solution for that. So joining us today is Daniil. He is the CTO for Unlink VR. You can check them out at Unlink, UNLINK-VR.com. But Daniil, thank you so much for joining us on the program. How you doing?
Fine, thank you. So let me start explaining what exactly are we doing. Right now,
Sure.
I'm sitting at our booth on CES and talking to you guys to bring it the idea. So what we do is we replace wires with lasers. It is obvious that we need to replace wires for VR headsets, but the problem is that the high-end ones of them, you can think of even such kind of headsets as Vario, for example. They have two wires connected to that, and it is clearly not great for immersion. So what we use an optical signal, which is known to be the fastest way to communicate. It is much faster than radio and even much faster than you can get with an electrical cable. And it doesn't have much limitations in distance. So we selected the technology. What we basically do is that you can see that in an image
Right.
which you just stream right now. We place some transmitter in the corner. The transmitter will look something like this. And it will send the laser beam. Sorry.
You're good.
It will send laser beam to the receiver. The receiver is a tiny sensor like... let me show it to you.
Yeah,
Like
and by the way, so for everyone out there who's simply listening, you can check out the video of this after the fact. But he's showing some of the sensors, and they look like little domes. You may recognize them as like little security cameras, but those are the laser transmitters that you would put up in the different corners of your room. And you're holding that's very small.
A receiving sensor. Yeah, very small is a receiving sensor, which will be located, for example, on the head, at the top of the head, like this one. And then it will send signals over to the device, which is like a hub.
Yep.
With a multiple interconnect for all those wires from the sensors. And then it will convert the signal from the optical back to the video signal to the VR headset. And also other signals which are exchanged to the computer. So the idea is quite straight. If you take radio, you're quite limited in terms of how many people can play in a similar space simultaneously. You're limited in the bandwidth. Say Wi-Fi would give you about 1 gigabit per second. Optical will give you 40 gigabit per second easily. And basically, if you replace a module with something faster, like 100 gigabit per second, which isn't a really unusual device, you can go even faster. And important thing is that radio is pretty much, if you talk about the range which is useful right now, it's pretty much already topped. It won't go faster, or at least much faster. And what if we need it 10 times or 100 times faster than the fastest radio can do now? The answer is we go to optical, which is basically the same waves, but much, much higher up in frequency. And they allow you to transfer like terabits of data per second. whatever. And it will allow further technological development, and it will not bottleneck our future progress in VR headsets and such.
Gotcha. And no, this all sounds, like very good technology for the application. And I'm kind of curious, pass sensors have been used for, I'm sure, cost effectiveness reasons and things like that. But lasers in general, I mean, I was reading some of the specs that you have up on your site, 40 times the speed of Wi-Fi. There are some limitations. Tell us about, are there any special considerations people have to do? I mean, they already have to do so many considerations for VR, but lighting conditions, line of sight, that whole thing. Like, how do you handle some of the limitations of lasers?
Okay, the line of sight is an obvious problem. Like the laser, it can bend over you, right? It has to go straight. And the thing is that it is the same problem for very high frequency radio. If you go like 60G and such, you'll need the same problem. It can be obstructed by hand or such. It doesn't penetrate body very well. So it is pretty much the same problems with radio. But the thing is that it has the same problem, but not the speed which we have. So if you have around the same troubles, why won't you go for lower speed if you can go for same troubles and higher speed? And that is basically the first thing to do. How do we play around that? We use multiple receivers located, for example, multiple on a headset, or a few of them will be located around your body, which isn't great in future perspective, but for first time it might be acceptable. So the thing is that if you use few mirrors, for example, then the laser can bounce off the mirrors located in the corners of the rooms, right? And reach you from different directions. And if you have, say, even just 3 sensors spread around your body, and you have 3 points from where the laser can go, it will make it virtually impossible for you to cover all of them at the same time from all single direction. As long as there is at least one way for a laser to hit the sensor, at least one of them, you'll get the connection. And it will hop from the obscure connector, from obscure sensor very soon, very fast. So you won't notice the problem, even if you create it.
Yeah, no, and it sounds like a great solution. And in some of your testing, and of course when you put this product out, what are some it sounds very good. 40 times the speed, great connectivity, multiple people in the same area. But in your testing, when it comes to actually implementing this, how does it feel in VR? Like, is it like the benefits are more responsiveness? Is it better accuracy? What are the most notable benefits of using your system?
So it is that you don't have to go for trade-offs. Like right now, if you go wireless, for example, it is certainly like a benefit going wireless. But right now, if you do it with Wi-Fi, you get latency plus you get compression. And so far, compression might work in actual games as long as they are drawn in like cartoon style with a very simple textures with no active background. There's no, say, trees with leaves and grass actively moving, blown by the wind around. As soon as you get to realistic graphics, you won't be able to compress the video down to such a bandwidth which can be carried over by radio. So an advantage is that you don't have latency because we don't need to compress the video, and second, you don't have artifacts, and you can actually transfer a very realistic, beautiful picture over this channel, because what you can compress well doesn't look well. There is so you can have great image quality, and you have literally no latency at all for your device, which is very important for VR for sure. There is a benefit.
Yeah, it really sounds like all the benefits of wired, but with also the benefits of wireless.
Absolutely.
And so you have your booth there, you're showing it off. Are you hoping to get this in the hands of consumers? Are you hoping for hardware partners, to kind of pick up the technology? How do you see your technology working itself into the ecosystem?
So we have a few ways of cost development. And one of them is selling this like an accessory to retrofit some headsets. But I see the future is that it will be integrated in the actual headsets, and will be either sent as an IP company which will license its technologies, or we will we will work like OEM partner, and we will provide some hardware solutions to integrate in the final devices, so that all the manufacturers can benefit from it. And basically that is.
Yeah, no, and I think you explained
I
that.
see it that way.
Yeah.
And the other question is, am I going to get it to consumer hands? Right now, it's somewhat a decent goal. We're looking for the investment to turn all our prototypes and lab setups into an actual product, so that we can make some alpha testing and continue further development. I wouldn't say that we'll get it to the market in less than say 2 years for final consumer. But in a year or so, it can start appearing in B2B applications if we get the investment and manage to move forward with this device.
And really, I really like the fact that your solution isn't much different than, I guess, kind of radio waves and, sensors and cameras that are already set up, but it's much more accurate. And so there's not going to be that learning curve of how to set up these sensors, but it's going to have a lot of benefit, and that's going to be great for, what's already happening and how they can work it into it. So Daniil, I want to thank you so much. I think that was a good recap. I hope that you're having a great CES. I know it's a kind of a different one, but thank you for taking the time and talking to us.
Thank you. See you next time, probably.
Absolutely. And everyone, once again, Unlink VR, UNLINK-VR.com. We'll have a link to it over at Computer America. Until next time, everyone, thanks again.